All right, so now we're back. We've set up our solver. We've got everything ready to go. And so we're just going to hit the button that says solve. And then it runs through, and then we get our happy box. And it's happy because it says it found a solution. All constraints and optimality conditions are satisfied. That's wonderful. That's exactly what we want. And so I also want to bring out an answer and sensitivity report to take a look at. So we'll hit OK. You'll see it spit out those reports. And so taking a look at these, what do we got? Well, we know that to come up with the optimal solution, we need to make 560 basic 1200 XP computers, and that'll give us a total profit of 199,600. Okay, so from there, let's take a look at these reports and see what's going on. Let's start out with the answer report. Okay, and so, a couple things. The engine, Simplex LP. Okay, so this just really, the simplex method guarantees the best answer, is really what it comes down to. And let's take a look at this. This is the pretty cool part. After going through all of that, it's a little dark. Found the optimal solution in less than 1 second. Not even close. It's like a lot more than that. So there we go. Everything taken care of. Great. So let's look at what these different things in here mean. So an objective cell, let's go down to the variable cells here and let's look at this part. We've got, hey, that says integer. What are we talking about here? The integer, it says continuous. So, well, this is giving us that the variables are continuous. It means not integers. Therefore, could be fractional. I can't spell today. Oh, wait, I can never spell, so fractional. Okay, so we are going to deal with integer programming later, and which is where we'll force these to be integers, but this is what we have right now. So these are continuous and non-integer variables. So the next thing I want to look at is, let's look at this thing here, the status. Now you'll notice that we've got these two words that pop up, binding or non-binding. So a constraint is binding if you've used all of that constraint and there's no more. So basically labor hours for assembly, if we go back here, you'll see that we used 10,000 hours for assembling time. We used all 10,000 hours. That is a binding constraint. There is no more. Same thing with number of XPs to produce. We can only make 1,200 of them. And so we made 1,200 of them. There is no wiggle room there. That is a binding constraint. So a non-binding constraint means that, so the binding constraints, they're what are forcing the final solution. The non-binding constraints are. So we can change, we would be able to play around with these to make changes because we have some of those units left. In fact, and what we call that is slack. Slack is the number of units that we have left. So for like labor hours for testing, we had 3,000 hours available. We only used 2,960, which means that there are 40 hours of testing time that we're not using. So, great. What does that mean? Well, if we were in a company and we had 40 hours that we weren't using, and it doesn't matter if they were there or not, I mean, 40 hours is one person's entire time for a week. Well, maybe I can reassign one of the people that was doing testing on this line to some other job. because we don't need what's going on. And if we look at the sales thing, well, we could have sold another 40 basics, but we just didn't have the supply. So the entire idea of binding and non-binding constraints is huge, because it's incredible the amount of information that they give us, because they identify what's limiting us in the problem. So once again, like I said, we got 40 labor hours. We can move that around. Oh, we can sell 40 more basic computers. Well, how could we do that? We could sit there as a company, as somebody that's running the operation, and go, well, what do I need? What resources do I need to free up so I can sell that other 40 computers? Because we have that unsatisfied demand. And so as you go through this, we'll be using this as a critical thing to realize what the binding and non-binding constraints are, so we can optimize what we are doing. So let's go and let's look at the sensitivity report. This gives us similar information to the answer report, but it's talking about the sensitivity of what's going on. So there's a lot in this one. And so this provides sensitivity analysis on the objective, how the objective is affected by each decision variable. So notice this is broken up into constraints in variable cells. And so if we take a look at things, we have our final values here, and our final values, those are just drawn from our final model. And so let's pick apart some of these, and the first one is, let's look at this reduced cost. So what does the reduced cost mean? Well, the reduced cost indicates how much the objective coefficient of the decision variable can change before the optimum value that we've picked out change. So what does that mean? So I look at it, the basic computer. It's got a 0. There is no amount of money that I could reduce the cost of the basic computer to change the mix that Solver's already given me. Because Solver is going to try to maximize those XP computers first, because we get the most profit from them. Now, if I look at the XP computers, it says reduced cost 33. If the profit margin on the XP computer decreased by more than $33, that is going to change the mix. So if I go and I reduce the profit margin on the XP by $34, then we'll get a different answer from Solver, because it will need to prioritize things differently. And this kind of gets into this allowable increase and allowable decrease item here. And so that is talking about where things are going to change. Now, as you can see, allowable decrease, $33. Once we decrease that, the optimal solution will change on the XP. And you'll notice that we've got 1 times, that 1e to the plus 30 is just Excel shorthand for 1 times 10 raised to the 30th power. That is basically Excel's way of saying infinity, because you can increase that number by whatever you want, and it's never going to change the mix, because we're already maximizing out how many XPs that we have. So there's nothing that can be done with that. So more interesting is we sit here and we look at the number to produce on the basic. So the allowable increase. So if the profit margin on the basic increases by more than $27.50, then what's going to happen is the mix will change, because now you're at a point where it makes more sense to make more basic computers. Much in the same way that, as I said, we can drop it by $33, more than $33, and that will change things for the XP. And so those are the important numbers here. And so Same thing, allowable decrease. If the profit margin decreases by more than $80 on the basic, then the mix will change. Now, if you remember, the profit margin on the basic is $80. So if we reduce it by more than $80, that means it's actually costing us money to build a basic computer, and so we'd want to zero that out. So those are important numbers to take a look at when we're looking at the variable cells. In the next video, we're going to come down here and we're going to talk about what's going on in the constraints.